Question number 6. Two vectors of magnitude 10 are perpendicular to each other. In those two vectors, ratio between magnitude of the difference and magnitude of the sum is equal to. Right. Now two vectors here equal two vectors, right, are perpendicular to each other, right, like this. Suppose here value, if it is a, here also a, right. If we consider about the sum, here is perpendicular, you can find the resultant using Pythagoras. Here a, here a, now here a plus a. Now the difference a minus a, a minus a mean a plus minus a. It mean here a, now minus a, it is opposite. We know if it is multiply a vector in a minus sign, right, the direction become opposite. So here also the magnitude, it is given by the hypotenuse. So here the magnitude value, here a, here plus, here also magnitude the same when two sides are equal, here also same. So the ratio should be, we can see the hypotenuse in both instances it is equal. So it means the ratio between sum and the difference should be 1. So answer 5. Okay, question number 7. The figure shows the velocity time graph of an object starting with a velocity of 32 meters per second and moving with a uniform deceleration of 0.5 meters per square second. Its displacement during t equal 8 second to t equal 10 second is, right. Here ask about the displacement, right, in this colored area, right. So we know in the velocity time graph, right, the area covered by the graph, it represents the displacement of that motion, right. So if we know, if we can find the value of x and the value of y, right, we can find the area of this trapezium, right. So here we can find these value, right. Here's the slope. We know acceleration is represented by the gradient. Here it is given as 0.5. So here if we apply, so this 0.5, it is equal, right, x minus 32, time taken here it is 8, right. So here it is 4, so x here it should be minus deceleration, right. So it is 28 meters per second, right, it is 28. Now y, now here same gradient, now y minus 32, it is 10, so 5, y should be 27, right. Now you can find the area, right. So area 28 plus 27 over 2 into 2, 10 minus 8, 55 meters. Answer 1. Okay, question number 8. Velocity time graphs of three objects x, y and z are shown in the figure. A, there are three statements. A, all three vehicles are moving in the same direction. B, in the beginning they start from the same place. C, at time t2 car z is ahead of other cars. Here, right. So here if you consider the first statement, all three vehicles are moving the same direction, right. Here the velocity time graph, right. We know there's a velocity vector, right. Here we mark when the object it is moved to the certain direction, it is plus. If it is change its direction, right? At that moment we mark in the negative sign, right? Here it is minus, v minus, but here you can see all are marked in the positive region. So statement A, it is correct. Then B, in the beginning they start from the same place. So we can get some data using velocity time graph is initial velocities, right? Initial velocities, here it is x, here y, z, right? So we can see x, it start with the 0 velocity, right? And y and z is certain velocities, right? And the area covered by the graph, it is represent the displacement, and the gradient represent the acceleration. We cannot say, right, we cannot get an idea about the initial displacement of an object, right, using the velocity time graph, right? So according to that, here in the beginning they start from the same place, so we cannot say exactly all the three objects are start at the same place, right? So it is not correct, right? We cannot say exactly, so be wrong. C, at time t2 car Z is ahead of the other cars. So here also based on the displacement, right? So we can see we can get the final displacement, we can get idea about the final displacement of each vehicles, right? We cannot say at the time t2 here, right? Car Z is ahead of the other, right? We cannot say it exactly, right? So we can say when t2, what can we say about the velocity of x and z? At that moment velocities are equal in x and z, right? Cannot say about the where the object is, right? So here also cannot say exactly, so C also wrong. So only A is true, so answer 1. Right, question number 9. ST graphs of 5 objects are shown in figures, right? Here there are some graphs is given. Of these, the rest at the beginning are, right? So it means which object or objects are started the rest, right? If we consider about the A, here we know rest means the velocity it is 0, initial velocity is 0. It means the velocity represented by the gradient of displacement time graph, right? So here the first object A, we can see it is started with a certain angle, right? It means it has some gradient, so it has initial velocity. Now here the curve graph, but it touches the x axis, so there is no slope, no gradient, no theta. It means no velocity. It means velocity is 0. So here start with rest, so B start with rest. In C also the curve graph, you can see it start with the maximum, make the maximum angle with x axis, right? So it is make the 90. So we know tan 90, we know gradient represented by the tan theta. So tan theta it is 90, tan 90 is infinity. So maximum initial velocity has the C object, right? Then one is touches the y axis, right? It has maximum velocity, so it is not the answer. So here D, what is the difference between C and D? Only the difference between C and D. D has an initial displacement, right? It has initial displacement, the positive displacement, right? The D object start with positive side of the displacement with the maximum velocity, right? And gradually it is decreasing, it means the deceleration to the positive side. So it cannot be the answer. Then E, now it is shape same like B. So what is the difference between B and C? Here also in the E object started the certain displacement, initial displacement, right? So E object start with this positive displacement with 0 velocity. You can see if we draw it, right, the tangent, it is parallel to the x-axis. It means there is no slope, right? The value of gradient that represent by the graph, it is 0, right? So velocity, so initial velocity it is 0. We can see gradually it is increasing and finally it become maximum. So this acceleration it is represent. So these are the to answer, right? Here u equals 0, B and E, answer 4. And question number 10, the velocity time graph of an object is as shown in the figure. Below are 3 statements about its motion. A, at P and T the magnitude of the acceleration is maximum. B, the motion from S to T is deceleration in the initial direction. C, in S and U the direction of the motion is same. True of these are, right? Okay, so here you can see, right, the gradient, right, of the velocity time graph represents the acceleration, right? So in the first statement, A at P and T, here and here, you can see it makes the maximum gradient, right? Here the curve, but if we draw the tangent, it's maximum. So here P and T, it has a maximum acceleration, right? So A, P and T, the magnitude of acceleration is maximum. So A statement, it is correct. Then B, the motion from S to T is deceleration in the initial direction, right? So here when moving S to T, right, so here is region is positive region, right, that I have mentioned earlier, right? Here if we draw the tangent, what happen? It is tangent, it is increasing, right? So the slope, it is increasing, and gradually it is increased, it means accelerate to the same direction, right? So if we consider about the nature of motion here, start with the maximum velocity and gradually decreasing called deceleration, and at the R it become rest for a while, then again decreasing, increasing its velocity, right, when past the S, again it is obtain the maximum velocity, right? Right, so if we consider about the nature of motion of this graph, right, so here start with maximum acceleration, right, with 0 velocity, right? So here is gradually increasing its velocity, right, and it means here gradient, right? Acceleration, it is, you can see acceleration, it is decreasing, gradient, it is gradually decreasing, and at the R at the R gradient become 0, it means acceleration 0 again, right? There's a gradient, right, it is increasing to the positive direction, right, and velocity it is decreasing, right, but the acceleration it is increases with the time, right? So S to T, when moving S to T, gradient of a graph, right, is a minus. You can see this minus value, right? It is make the obtuse angle with the positive side of x, right? When the gradient, or when the gradient it is make with the positive side of x, if it is acute angle, the sign of the gradient it is plus, right? If the straight line make with the positive side of x, if it is obtuse angle, we know it is the sign of the gradient it is minus. Now, right, the minus nature it is decreasing, right? It means acceleration, right, it means minus acceleration to the positive direction, right? So the deceleration towards the positive direction. So B, it is correct. The motion from S to T is deceleration in its initial direction, right? Then in S and U the direction of the motion is same. No, you can see, right, S and U it is opposite direction, right? So it is positive velocity, here negative velocity, it means directions are opposite. So here C, right? So answer 1, A and B.